All right, let's finish with review worksheet 5. So this is the back page here. Number 7, the graphs of the derivative f, g, and h are shown above. Which of the functions have relative minimum on the interval between -3 and 3? So it helps if we can create our slope sign lines for each of these derivative functions. So we know that x-intercept represents where slope is 0, so that's our critical point at 1. Anything to the left of 1, we see that these values are all below the x-axis, so that represents negative slope. To the right of 1, we see it's above the x-axis, so we get a positive slope. So we see what the shape of the original graph will look like. It'll decrease, hit a value at 1, and then start increasing again. Okay, let's look at the second graph here. Critical points at -1, and this looks like 1.5. So this portion represents above the x-axis, represents positive slope. This portion is below the x-axis. This represents negative slope, and then to the right, positive slope. Okay, so keep in mind you're looking at the derivative graph. So these y values represents slope, and they no longer represent location or your physical y value on the graph. Okay. And then the third graph, we have critical points at 0, and this looks at 4. Above the x-axis, so positive slope. Below the x-axis, negative slope. And then to the right of 4, even though it hits the x-axis, it's going to go back down in the negative region. So again, we have negative slope after 4, to the right of 4. So by looking at these three sign lines, we see there's a relative min here. So for f, there's a relative min here at 1.5. However, we don't see a relative min for this. Well, also 4 is outside the interval. So even if it did increase, even if there were a relative minimum at 4, it would be outside of our interval, so that wouldn't count. So only f prime and g prime graph would have relative minimum on the interval from -3 to 3. Okay, number 8, we're trying to match. It says the graph of f prime is shown. Which of the following could be the graph of f? So let's go through our sign line. Critical points at -1 and 1. Positive slope above the x-axis, negative slope below the x-axis, positive slope above the x-axis. So we're going to be expecting a graph that's going to rise, hit a maximum -1, fall, hit a minimum at 1, and then rise again. So the only graph that that's going to have those characteristics are really just between A and B. Okay, and it's kind of tough to see the difference between A and B. The only thing that stands out is that the slope is steeper for A than B, right? And what we can do to kind of narrow down between A and B is see that the slope, if you look at this f prime graph, the slope does hit a pretty high value, right? This is what, a slope of 7, slope of 8, so that's pretty steep. So we're going to get steeper. So we're going to be choosing the function that's going to have the steeper value, or the steeper slope. So we see that here, this graph, it does have the same general shape, but the steepness is all going to be very minimal. Okay, it's not going to be as nearly as steep as A, so A will be our solution. Okay, number 9. A graph of a twice differentiated function. That means we're going to find the derivative twice for a function. Which of the following is true? So we're trying to compare all the values for between f prime and f double prime at 0. So let's see if we can compare and find the values for the original function for f prime is 0 and f double prime is 0. So first, f of 0, we're just looking for order pair, right? This is f of x function. We're going back to looking at the original position function. So f of 0, 0, that's just the order pair. F prime of 0 is asking for what is the slope at 0. So you see that at 0, this graph is still rising. So this is a positive slope. So we're expecting a positive value at f prime of 0. Okay, f double prime of 0 is asking about concavity, right? Concave up means positive positive value. Concave down means negative value. So if you look at this portion, at 0, the graph is part of concave down. So if it's part of concave down, we're going to be expecting a negative value for f double prime. So what that means is that we expect f prime 0 to be the largest value, because that's a positive value, followed by 0, and then followed by the negative value, f double prime. So the answer choice is going to be E.